And thank you for watching this introduction to the track parser. What the track parser is it will break up a GPX, KML, or JSON track into legs and give you data for each leg. So for instance, if you went on a hiking trip, a climbing trip, a ski tour, or a bike ride or run, you can run your GPS. Either there's a number of apps that'll work. The CalTopo app, the GPX file will work. The Gaia GPX file will work. And a regular Garmin GPS, the GPX file will work for that. Other apps will work. Some of the free versions of paid apps, like Strava, will not work. You can download a GPX, but it doesn't come with time. And the track parser needs the timestamp for each track point for it to work properly. So I'll be testing more and more apps to figure out which ones work and which ones don't. But generally speaking, the free version of paid for apps like Strava and apps like that will not work in the track parser. But generic GPSs or app programs that just track you generally will work. So what we're going to do is I'm going to show you how this works with a little demo. What I did is I went on a bike ride. I was using the CalTopo app in this case, and I just tracked my ride. I never looked at my watch. I never did anything with my GPS on my phone except for start it and stop it at the beginning and end. And now I'm curious, how long did it take me to do certain sections? And I'm going to break up that trip. So the first thing I'm going to do is I'm going to choose the file, and I've downloaded the GPX file from my CalTopo app onto my laptop, and this is it here. And I'm going to upload it into the track parser. The track parser is, first thing it's going to do is simplify the line a little bit. That removes kind of errant track points, and it increases the accuracy of the data. So I'm going to download that, and it'll go into the same file. Now I'm going to open CalTopo, and I'm going to import both the smoothed out version and the original, and I'm going to upload them into CalTopo. So this is the trip that I took, and I uploaded them both so you could see how the smoothed out version kind of straightens the lines out a little bit. I'm going to change the color of the original to black, just so you can tell the two lines. And I'm going to just toggle, and you can see how some of the line sort of simplifies a bit. Now this was a bike ride, and the faster you go, the less the simplification will have an impact. If you're going really slow, heavy pack, post-holing, there'll be a lot of error in your GPS. This will straighten out that line, take out that error, and give you more accurate data. So at this point, I have my track into my program, or excuse me, in my smoothed out track into CalTopo. All I'm going to do now is add some waypoints. So I'm going to add a marker at the start, and I'm going to call that the start. I'm then going to move down, and I'm going to break this up in a logical way. I travel some trails here to a tar road. How you break this up, it's your trip. How you want to know like how each leg went is up to you. I'm going to call this Hales, and that will be the end of my first leg. Then I'm going to go a little further, and I'm going to put a couple points in just so you can see the process here. I'm going to add another waypoint, And that's where I got off the tar road. And I'm going to call that the top of Hales. So that's the top of Hales. And I'm going to put another one here at the top of Whitehorse. And these will be the last couple that I put in, and then we'll move it right along. I'm going to add one here just before where I took my rest. And I'm going to use a keyword. I'm going to call this the transition at the top of Whitehorse. Now that word transition will be recognized by the track parser. And what it'll do is it'll remove any kind of bouncing around that happened. You can see originally there was quite a bit of bouncing around. That will add error. I was actually at a standstill, so I wasn't moving, but according to my GPS, because of the errors, because it's taking a track point every 5 or 6 seconds, it's off by a little bit. That will add distance and elevation gain or loss. And if you stop for 20 minutes, that can add quite a bit of distance and elevation gain or loss, giving you kind of errors in your data. So if I put it here, I can tell exactly how long I stopped, and it will zero out any elevation gain and distance. So now I'm going to add one more marker. This will be the last one that I do for this demo. And this will be the start of the descent. And so what I've done is segregated the transition or the rest. I use the word transition because I designed this most of the time while I was ski touring. And so this is oftentimes called a transition, where you're taking off your skins or putting on your skins, taking a little break. So this would measure my stop time. So what I've done, I have another CalTopo page where I have the exact same thing with all the markers in place, and I have my markers over here. I've colorized them blue. You can see I have my transition segregated at the top of Whitehorse. And what I'm going to do now is, so now I've broken up the trip into its legs. And so what I'm going to do now is export that. And I'm going to just get rid of my original, and I'm just going to export the markers. If I made the mistake and brought those in, the parser will know the difference between markers and this, but it's just a nice cleaner way of doing it. Export it. It's called Cliff Waypoints. I named the map, and it's going to go into the same folder. So now at this point, I can go back to the parser, and I can click to put in my waypoints. So I'm going to choose the file, then I'm going to put my waypoints, and I'm going to upload them. Now the parser is going through and breaking up the trip into legs, and I'll download the results. Now the results will come into the same file. So if I go to that file, I'll notice that I have my original track, my smooth track, my waypoints track, and a folder with my results. Now the results will come in 3 forms. There'll be a CSV file that we're going to ignore right now, but if you're a data geek, this will give you a nice, clean, comma-separated value data sheet so that you can work the data or maybe make charts or something like that as you like. The one that'll interest most people is this XLXS file, which will open up either in Excel, if you have Excel, or Numbers if you're just running a Mac. And the way it'll work is that each leg will be color-coded, and it starts out blue, sort of this gold, yellow, and then the red will always be a transition. If this weren't a transition, it would be this purple. So it goes blue, gold, yellow, purple, blue, gold, yellow, purple, except for transitions, which are specifically red. The red unfortunately won't show up on numbers. It's conditional formatting and numbers doesn't show up. But everything else about the transition will be the same. And you'll notice all the data is zeroed out. So that way your altitude change is 0, everything is 0, but your time is measured. So I actually stopped only for 3 minutes and 39 seconds at the top of Whitehorse. I was kind of moving along. So this, I'll just break out the data for you. The date that it happened. I have the weather data shut off because I'm using a data service that charges me. It also in the app right now delays the amount of time. And so it takes a lot longer for the parser to work to get that data. But in the future, if you'd like, you can get you'll be able to get weather data, which will be temperature, wind speed, wind direction, wind gust, and humidity from the nearest reporting weather station of the start point. It's pretty interesting, especially for ski tours, to know that information, and it may be interesting for other people, especially in mountain sports. So now this will be the actual start time and end time. In local time, it will correct the UTC, so it will always be the local time of where the trip occurred. The elevation where you started, the ending elevation, and then the actual altitude change between the start point and the finish point. The distance you traveled, the amount of time it took. Now we're going to get into this total ascent and descent, which requires a little bit of explanation. This total ascent and descent is the actual ups and downs of that leg, all the ups and all the downs, according to your GPS. Now, your GPS will have some errors, as I mentioned before. They've been diminished by the smoothing, but altitude, GPS altitude is well known to have some errors. What you'll notice is we're going to skip over the Munter rate. I have it segregated by the Munter rate. Another total ascent and descent. And this is derived from a digital elevation model taken by the Shuttle Radar Topography mission. And this goes on to the internet. The parser goes on to the internet and gets the elevation points of all the track points from the Shuttle Radar Topography mission. And what you'll notice is there's some difference. Here, there's not a huge difference. According to the SRTM, I went up 164 feet. According to the GPS, I went up 150 feet. There's a 40-foot difference in descent. Both of these have errors, so it just gives you a way to compare and give you a better idea of your total ascent and descent. It's hard to get total ascent and descent without errors. So by comparing these two, you get a little bit more accuracy as far as like a rough estimation. I basically would call this, I went up and down about 150 feet and 170 feet. I just kind of average out the two. The Munter rate, for those who understand the Munter rate, this was the Munter rate that I was traveling at. This is the mile pace. So for runners, you get your mile pace. And for those who care about their speed in miles per hour, the direction of travel is, imagine drawing a straight line from the start point to the finish point. This is the direction of travel you were going. And then if you took that straight line, if you factor in the elevation change, basically you get the hypotenuse of a right triangle. So that allows the parser to figure out the average angle. This was a pretty flat trip. But you can see I get some steeper angles here. This is really useful for ski tours. If you make your descent, your ski descent, a segment of your ski descent, a leg, this will give you the average angle of that leg. And because you have direction of travel, that also gives you the aspect of the slope. Then you get the distance in a straight line. Again, if you drew a straight line from the start point to the finish point and measured that distance, And then that's all kind of nice to compare with your actual distance traveled to see how much zigzagging you did. You can see my straight line distance on my second leg was 0.65, but my actual distance traveled was a mile. Zigzaggy roads. And then finally, your endpoint. So the start and end point are defined based on what you named them, and then the running time. So this is the time since the start. So my entire trip took 1 hour and 21 minutes for this bike ride. I have some totals on the bottom. What I've done is I totaled the ascent and descent, both of the SRTM and the GPS, so that you can compare them overall. And then to give you another data point sort of to compare with, the altitude change, I've added up all the positive numbers of the altitude change column. Technically, if you did all this, it comes pretty close to zero. It should technically zero out if it's a circular trip. In other words, if the start point and the end point are the same place, your altitude up and your altitude down should be zero. But if you add up all the positive numbers, it gives you a bit of a comparison from these others. So I would just say my total up and down on this trip was roughly about 1,800 feet. And then, of course, the mileage is totaled. So that's the spreadsheet data, and it's just kind of nice to have that, get some information about each leg and your total trip. Now, the next data point that I have, if you notice, I'll go to my Finder here first and go to, oh, I was in my results, I'm sorry. Go to my results, you'll notice that there's a data JSON file here. That data JSON file will import into Caltopo. So I'm going to do that now. I'm going to import files and go to my results and import that JSON file. And what I'm going to do is click off the markers and click off my two original lines. And what you'll notice is it's the exact same track, but it's broken up into legs and colorized. The colors correspond directly to the spreadsheet. And if you click a leg, what you're going to get is some basic data. So where it started, where it finished, the amount of time that leg took, and the elapsed time since the start. And so you have a map representation of your data. I can add a bit more data to this, and I may. I just didn't want to stuff it with too much data, but I'm thinking of putting altitude gain and loss, but I'm not sure which one to add, the SRTM or the GPS data. If anybody has a preference, let me know. I may try to make it so that in the future, you'll be able to decide what data to put into this, but that'll be a little ways away. Right now, I'm working on the deployment. But this part of the program can and probably will get a bit buffed out in the future. Anyway, that's the little guide to the track parser. I hope you enjoy it or enjoyed it, and I'm looking forward to getting this deployed for people to beta test it and work on it from there. If you like the idea and think this is going to be something you'll use, please be in touch. Thanks again.